Hi, welcome to our channel. In this video, we're going to see this Leetcode problem number 2, add two numbers. So in this problem, you are given two non-empty linked lists representing two non-negative numbers. The digits are stored in reverse order. Each of their nodes contains the single digit. Add the two numbers and return it as a linked list. So you may assume that the numbers do not contain the leading 0 except the number 0. So what we have given is we are having two numbers which are represented by a linked list, and those numbers are already been in reverse order. So for example, this is the one number which is represented like this, and this is the another number which is represented like this. Okay, now let's see how we can solve this problem. So before going to solve this problem, first we need to check what are the constraints there for this problem. So first constraint that we can see, the no list will be empty over here. So and another constraint is numbers are positive, they are not negative, and list are already been in reverse order. Okay, so in this problem we'll see which data structure we have to use and what will be the algorithm, and then we'll see the time complexity and the space complexity. So first let's discuss how we can solve this problem. Okay, so for data structure we can see that the numbers are already been given in a linked list, and as we know that the usual method that we already be using is how we can add the two number is like this. For example, this is already in reverse order, so actual number would be 3, 4 and 2, 342. This is the actual number, this is actual first number, and now second number is 564. Actually it is in reverse order, so actual number would be 4, 6 and 5. Okay, so here first number is 342, second number is 462. The usual method that we already using is we first start from the unit place and keep on adding, and whenever there is a carry it will be transferred to next digit. Okay, for example here 5 plus 2 is 7, next 6 plus 4 is 10. Now here there is carry 1. Okay, so it will be transferred over here. So now 4 plus 3 plus 1 is 8. So our answer would be 807. But as we can see, the numbers are given in the form of list in a reverse order, so our output will also be in a reverse order. Like our output would be in this case is 7, then the next number would be 0, then the next number would be 8. So this would be the output for this. So here we already see that how we can which data structure we can use, that is linked list. Okay, this is the linked list. Okay, so another one is which algorithm we can use. So for algorithms we already see that we keep on adding the digits from unit place to next place, and if there is any carry we keep transfer and keep on adding. Now let's see how this linked list representation is there and how we can add this. This is the usual method. Now we can see how actually it will be implemented. Now first the list is given 2, 4 and 3 in a reverse order. So list is, this is the 2, the next node is 3, next node is 4 actually, the next node is 3. Okay, so another list is 5, 6 and 4, 5, 6 and 4. So how we can add this? One constraint that already been given is each node will have a single digit. As in linked list we can see that we can store one is the value and there is a next node. This is the structure of the linked list. If you want to check, we can see in the problem statement in the code section also, here there is a linked list defined over here. It has one data item called value, another is a one next item. Okay, so come to here. So how we can add it? So usual method is we start adding from the unit place. So this is the unit place because it is already in reverse order. So see here, if you add this number 5 plus 2, this is the 7. So our result would have the first node as 7. Okay, now here as we already see that the carry is 0 in this case. Initial carry is 0, and now after adding this also 7, there is no carry at all. So now come to here, 0 plus 4 plus 6, which is 10, but we cannot put 10 in a node because a node contains only a single digit. So for next we will be able to, will only store unit place, which is 0. Okay, now our carry will become 1. Next we'll add this carry, then these two numbers 4 plus 3 plus 1, which is 8. So our output list would be 7, 0 and 8. This is our output. Now if you directly implement this, so in this case let's discuss the time complexity. For the time complexity, we can see that we're going to add these numbers, means all the digits one by one. So if let's say first list had m number of nodes and the second list had n number of nodes, so what will be the time complexity? So as we see in our procedure is we will keep on adding all the digits, okay, and we'll digit one digit only once. So the time complexity would be maximum of whatever will be the list. Why the maximum? Because in some cases it might possible that one list is too large, like this is 1, then 2, then 3, and another list would be like 1, 5, 7 and 8 and dot dot dot, anything will be there. So in this case when we keep on adding, this 1 plus 1 will become 2, this 2 plus 5 will become 7, this 7 plus 3 becomes 10. Now there will be 0, then one query and dot dot dot. So it might possible that key one list got empty. So in this case we have to visit all the remaining nodes over here. Okay, so whatever will be the maximum, that many nodes we have to visit. So time complexity would be maximum of m plus n. Okay, so this will be the maximum of m comma n. So what is m and n? M is number of node in the first list, n is the number of node in the second list. So this is the idea behind this. So in space complexity we can see that we have created another list in which we have stored the result. But if you directly implement this, in this case our space complexity would also be order of m plus n. But we can see that we have the list and we can directly update one of the lists. For example, instead of creating new list over here, we can directly update this result. For example, while we adding this 5 plus 2, we can directly update, let's say first list would be 7. Now similarly carry will be 0. Now here 6 plus 4 10. So here we can update 0 and then 1 will be the carry, then 1 plus 3 plus 8, this will be 8. So instead of using this new list, we can make anyone, either first list either the second as the output. So we do not use any extra space other than some few number of variable. So in this case our space complexity would be the constant, which is order of 1. So we have seen the data structure and how we can implement, which is algorithm, then time complexity and the space complexity. Now let's see how we have implemented in the code section. Okay, so in this, here I have taken one variable which is called carry, that we have seen already how to use this. And now this is the first loop. In this we will going to see this will be run till both the lists are there. For example, we have taken one variable called answer, another is called last. So here we can see that what is the variables that we have used. So let's say this is the first list, so this starting value will be L1, and this is second list, this will be L2. Okay, so these are the two variables that we have used, L1 and L2, and the other variable is result, not result, which is last. Okay, LAST. So this is the our variables that I have used, and one carry variable which is initially 0. Okay, so these are the variables that I have used. Now let's see how this L1 L2, we add these two variables, and now whatever will be the result, that will be the pointed by this last node. Okay, now keep on updating like this. Here we can see these are the answer and this is the last variable. So answer is here, we can see this answer is this one. If we make first list as our output, so answer will be the first list, and if you want to second as our output, so it would be second list will be our answer. So in our case I have used first list as an answer. Okay, and keep on updating the node value. So you can see here answer is pointing to first node and last initially will be null. Now our loop will be run till both the lists are there, means if any one of the list is empty, then it will be come out from the loop. So in this complete loop we are just going to add these value. For example, this one L2 value, L1 value, and this carry, we add all three value. If these value put together will be greater than 9, in this case we'll have some carry generated. Okay, now if value is less than 9, let's say 4, 5, 6, anything, so there will be carry 0. So we initialize carry as 0. If the number will greater than 9, then there will be carry generated. And now in case of carry, we just have to modulo 10 to find the particular digit that we want to store there. Okay, this loop will run until both the lists are present. Okay, if in this case, if this loop will run when second list got empty. For example, if there is only the first list got empty, then second list got empty, then there will be only one list. So in this case we have to just keep on adding the L1 nodes. Okay, so first we add carry and then we'll check if it greater than 9, then another carry will be generated, then L1 will be pointing to the next node, then again we'll check this, add with carry and check if greater than 9, again next, and similarly in similar fashion it might possible that first list got empty and second list is not empty. Okay, so in that case we have to traverse the second list completely. So how you can traverse? Keep on adding the carry over there. Add the carry, if number greater than 9, another carry will be generated, then point to the next node, another carry will be generated, add it, and next. In the end it might possible that after adding all the numbers we'll have some carry left out. So for that we have to create a new node. Okay, so let's say after adding these two numbers, if there is some more carry generated, let's say carry is 1, so in that case we have to create one more node, 1 over here. So for that this is the case. So last node is pointing, always last node is pointing to the last node of the output list. So in this case we have made one first list as output, so till here our last will be here pointing to this last node. Okay, so in this case if by the end our carry is 1, so we need to create one more node over here which is 1. Okay, and last will be pointing to here. So this is our result. So this is the way I have implemented this. Let's check it. Yeah, I have